Today let's talk about determinant, and I would like to use this question to illustrate some properties of the determinant. Here is the question. We want to find A, B, C that they are all different real numbers so that the determinant of this matrix is equal to 0. Notice that the reason we have this condition is because if A and B are equal to each other, for example, then the first two rows will be equal to each other. Then in that case, we know that by one of the properties of the determinant, if two rows are the same, then the determinant is just automatically equal to 0, right? So that's not that fun. Okay, let's see how we can approach this then. Of course, one way is just go ahead and compute this 3x3 matrix determinant, but I think the algebra will be pretty messy, so I'm not going to go through that. Instead, let's see how we can simplify this by using the properties, so hopefully at the end, the expression is nicer and we can come with a condition to help us find out the ABC. Alright, one thing to note is that we have the 1 plus, 1 plus, 1 plus in the third column. This is what we can do. This is the sum property of the determinant. We can actually break this down into two determinants. The first one is just A, B, C, and then A squared, B squared, and C squared. Notice that the first two columns are the same. And then for the third column, just write down the 1, 1, 1, like this. And then we are going to add it with the determinant of, again, you copy down the first two columns. And then for the third column, you have just this, A cubed, B cubed, and C cubed. So this is a sum property of the determinant, and this is legitimate. And let me give you guys a little warning on the side. Whenever you have the determinant of the sum of two matrices, let's say A plus B, this right here is actually not always equal to the determinant of A plus the determinant of B. Unfortunately, that's not the case, and perhaps I'll do this for another video. But this is legitimate though. Now, you see, here we have A squared, A cubed. We can factor out an A from this row. And when we do that, we just have to multiply the result with A. That's all. And likewise, we can do the same for factoring out the B right here and factoring out C. So that's good. In that case though, we will end up with 1A and A squared. And we happen to have 1A squared, but it's just at a different order, right? So we are going to do two things right here. The first thing is that I would like to put this into the order that we are about to get. Namely, I'm actually going to move the third column of the first matrix to the first column right here, and then the first column to the third. Namely, just interchange them. We can do that, but you have to remember to multiply the result by -1. So let's go ahead and do this. -1 times, we will have 1, 1, 1, and this right here stays A squared, B squared, and C squared, and then A, B, C, like so. So that's okay. And then for the second part right here, I'm just going to factor on A from here, and then B and C, and then we will end up with 1A squared, and then 1B squared, and 1C squared. So that's pretty good. And by the way, that's a 2. All right, so this and that, they're almost the same now. Well, again, just go ahead and switch them. And we just have to multiply the result by -1 again. So we see this becomes -1 times -1, and then we have the 1, 1, 1, and then A, B, C, A squared, B squared, and C squared, and then we just have to add it with A, B, C, and then this thing again, 1, 1, 1, A, B, C, A squared, B squared, C squared. I think it's pretty cool. Now, what else can we do? Well, notice that because these are the same, and remember, determinant is just a number, so we can actually factor it out. So I will just put this down right here for you guys. This will be equal to, let me write this and that down first. We will have 1 plus A, B, C, and then multiply by the determinant of the 1, 1, 1, A, B, C, A squared, B squared, C squared. Okay, this determinant is easier to compute than that determinant. But this is still not the best. The best one that we like is the one that has a lot of zeros, right? So we are going to do some row reduction here. And what we can do is we can multiply this by -1 and add it to the second row, so we can put the 0 right there. And when we do that, the truth is the determinant stays the same. So that's so wonderful, right? So you can just do some row operations right here. Well, I will just keep it the 1 plus ABC in the front, and then I will just write this down for you guys. The first one stays, and then row reduce, we get 0, and then this becomes negative a plus b. I mean write it as b minus a. And then we have b squared minus a squared. And since we can do this to here, why don't we do it to the third row as well? So multiply this by negative 1 and add here, we get 0, c minus a, and then c squared minus a squared. Very nice, right? And now you can do the expansion right here, and you will just end up with a determinant of the 2 by 2 matrix, which is much better in my opinion. So we'll do that. So here, I will still keep the 1 plus ABC here, and then just kind of ignore this, ignore that. And this is a positive 1. Remember, when you do the expansion, you have to pay attention to the sign. Start with plus, and then minus, minus, and then plus, plus, plus. And the sign just alternates, right? So if you do the expansion right here, you keep the positive 1. And the beauty is that, well, actually, because of 0, so you can just ignore that. It's technically 1, right, times this. And then you add it with 0 times the matrix of this, that, but just 0 anyway, and likewise just 0 anyway. So whenever you have 0 in your row or column, you can just do delete this, delete that, and then just focus on the rest. So that's what I'm doing. All right, so 1 times the determinant of this, b minus a, c minus a, and then this is b squared minus a squared, c squared minus a squared. Perfect. Now what else can we do? Don't be lazy now, just go ahead and compute the determinant of this. And if you really want to do some factoring business, you can look at this as b minus a times b plus a, and then factor out b minus a. But I think we should be okay. Yeah. Anyway though, I'm just going to write this down. We have 1 plus ABC times 1 doesn't matter. And the determinant of this guy is just this times this, and then subtract this times that. Pretty easy, right? So we will have b minus a, c squared minus a squared, and then we have to minus b squared minus a squared times c minus a, like this. All right, so now as I told you, we can factor and just do the algebra. This right here is c minus a, c plus a, and this right here is b minus a and b plus a. So let's see, what do we really have? All in all, we have 1 plus ABC, and then from here we can factor out b minus a, so that's nice. So we have the b minus a, and then we have c minus a, so go ahead and do that. And lastly, we have this minus that inside of the parentheses. So here we have c plus a minus b plus a, like so. And this right here, we can simplify it. You see, the a minus a is just 0, so of course this and that will be out. So the last parentheses is just nicely equal to c minus b. So all in all, we can come back here after all the simplification. Magic, pretty much. You can just erase all the work and just tell people that, hey, you know what? The determinant of this guy is just nicely equal to 1 plus ABC times b minus a, c minus a, and then we also have c minus b. Pretty good. Now, remember, we want this to end up to be 0, so we are going to set this to be equal to 0. And here is the time that we are going to use our condition. Notice that a is not equal to b is not equal to c, so that, of course, a and b are not equal. That means this right here cannot produce a 0. Likewise, this factor cannot be giving you a 0. Likewise, this cannot give you a 0 neither. So what can we conclude? The only hope for us to end up with 0 is that 1 plus ABC has to be equal to 0. Namely, ABC has to get due negative 1. So this right here is the condition. That's pretty much it. So if you want to produce a matrix in this particular form, all you have to make sure that is a times b times c. is equal to -1, then this right here will be it. And of course, you have infinitely many choices for that. Let me just give you guys a quick example. So you can take a to b, let me not be too creative, let me just say 2, b is equal to 1/2, so we get +1 so far. I need to end up with -1, so c is equal to -1 then. Okay? And then just plug in, then you will see that, let me tell you, we have 2 squared and 1 plus 2 to the third power, so we get 2, 4, 9, and then put a 1/2 in there, we get 1/2, 1/4, and then 1 plus 1 over 8 is 9 over 8, and lastly, -1, 1, and 0. Once you have this, you know the determinant will be equal to 0. Very cool, huh? Alright, so hopefully this right here kind of give you guys an idea of how we can use the determinant to help us simplify the determinant of the matrix, the property, so you can simplify the determinant, right? Alright, so that's it, and I'll do more for you guys. That's it.